AP Calculus AB, Unit 8, Day 4, Office Hours. These are the even answers. So the odds are in the back of your book. You can check your evens right now real quick. Pause the video if you need to. Okay, assuming you have checked all these answers, let's try them out. So number 8 says evaluate the integrals by making appropriate substitution. Hint, hint, use U-substitution. Now, let's see. So U equals usually what's on the inside, the inner function. Du equals 3dx. That looks good. Done with the 3. So I'm going to get a 1/3 in front. U to the 5th, du. That should be an x there, by the way. Okay, so this is going to be a power rule. Bump it up 1, divide by the new exponent, plus c. So we're going to get 1/18. 3x minus 1 to the 6th power plus c. Final answer. There we go. Okay, number 10. The integral of sine 3x dx. I think it helps split parentheses around what's inside trig. And we could probably go with u equals 3x, du equals 3dx. I think this is a problem that I would avoid u substitution on because it's just an extra number that pops out. I know an extra 3 is going to pop out. I put a 1/3. That fixes it. 1/3 cosine 3x, mean negative because the derivative of cosine is negative sine, plus c. Oh, wait. Anyways, that would be the answer. Let's see. If we were to actually use u substitution, it would be 1/3 sine u du, just 1/3. Then it'd be negative 1/3 cosine u plus c. And you write your final answer, negative 1/3 cosine of 3x plus c. So either way. But I think those are easy ones to not force yourself to use substitution. Unless it helps you get the right answer, and do it. 12 is going to be secant squared 5x. Again, the extra 5 is going to pop out. But we could do u substitution. U equals 5x, du equals 5 dx. Don't want the 5. So this is going to be 1/3. I'm sorry, 1/5. Secant squared u du. Secant squared is a derivative of tangent. So we're going to rewrite it back in terms of the original variable. 1/5 tangent of 5x plus c. All right. So those are the evens. The rest are odds. You should check those. 13 is e to the 2x dx. So I personally think, oh, you know what? I can totally avoid this. I could just be like, the antiderivative e to the 2x is 2x. It's gonna pop out an extra 2, so I'm just putting 1/2 in front plus c and say it's good. Or you could do use substitution. U equals 2x. Du equals 2 dx. Don't want the 2. Put a 1/2 in front. E to the u du. Antiderivative of e to the u is e to the u plus c. Replace it back with the original variable. And you get the right answer. 15 is the integral of dx over the square root of 1 minus 4x squared. Now, if we try u equals 1 minus 4x squared, which is always a good thing, at least to try, at least in your head, negative 8x dx, that's no good. There's no extra x. So this might be that special pattern, inverse sine, I think. Now, this has to be 1, which it is. Good. If it wasn't, you fix that first. What would you plug in there to get squared? That's going to be your u. U equals 2x. Du equals 2 dx. I don't want the 2. So when I rewrite this, it's going to be 1/2 du over the square root of 1 minus u squared, which is 1/2 inverse sine of u plus c. Final answer, written in terms of the original variable, 1/2 inverse sine of parentheses 2x plus c. 17. It's going to be the integral of t, square root of 7t squared plus 12 dt. Probably making the inside your u is a good call. 7t squared plus 12, the whole inside. Du equals 14t dt. That's going to work. I want a dt. ddt. Don't want the 14. It's an easy fix. Get a 1/14 in front of square root of u du, which is u to the 1/2, which is the power rule. Bump it up 1, divide by the new exponent, and multiply by the reciprocal, plus c. Final answer, back in terms of t's, 7t squared plus 12, so 3/2 plus c. There you go. Looks good. 19 is the square root of x squared, square root of x cubed plus 1 dx. Now, I usually, at least in my head, try the whole denominator, what's inside of it. And don't go for the inverse sign weird ones right away, because it might not be one. It might be simple. Du equals 3x squared dx. Perfect. X squared dx. So we got a 1/3 in front. Du, square root of u. That's u to the negative 1/2. That's going to be u to the positive 1/2 divided by the new exponent multiplied by the reciprocal. Final answer, square root of x cubed plus 1 plus c. All right, 21. 21 is x over 4x squared plus 1 cubed dx. Let's just try the denominator, 4x squared plus 1, without that, just what's inside the denominator. Du equals 8x dx. Perfect. I want x dx. Do you want the 8? It's an easy fix. 1/8 du over u cubed. That's 1/8 u to the negative 3. Power rule. 1/8 u to the negative 2 over negative 2 plus c. Final answer. In terms of x, no negative exponents. This is going to be negative 1 over 16 4x squared plus 1 squared plus c. Looks good. 23. E to the sine x cosine x dx. So here, pick what's inside. Hopefully the derivative of what's inside is on the outside. Du equals cosine x dx. Perfect. So that's going to be e to the u du. Oh, answer to e to the u is just e to the u. And then rewrite it back in terms of the original variables. Not bad. Okay, let's keep it going. 25. X squared e to the negative 2x cubed dx. Well, I think I'm going to go for that. U, negative 2x cubed. Du is negative 6x squared dx. Perfect. I want an x squared dx. I don't want the negative 6. So it's going to be negative 1/6 e to the u du. So it's going to be e to the u plus c. Final answer, negative 1/6 e to the negative 2x cubed plus c. Now, if I didn't want negative exponents, which I often say I don't, rewrite it like this. Right? That works. A few more. Okay, 27 is e to the x over 1 plus e to the 2x dx. So we could always try what's in the denominator, the whole thing. Sometimes that works out great. Du equals 2e to the 2x dx. So chain rule says take derivative of e to the 2x, get e to the 2x, and then multiply by the derivative of what's inside. That's not going to work because I need an x to the 1x. You might think, oh, that's close. Nope. So I think we need to start thinking more creatively here. Might be inverse tangent. What would you plug in here to get that squared? This has to be a 1. Fix that if it's not good. So I think u is going to be e to the x, and then du equals e to the x dx. Now that works. So this is going to be du over 1 plus u squared, which is inverse tangent. And then back in terms of the original variable. There you go. $29. Sine of 5 over x squared dx. Now, a lot of times you pick the denominator, but I'm going to say this looks more like the inner function. U equals 5 over x, or 5x to the negative 1. Du equals negative 5x to the negative 2 dx, or you could rewrite it as negative 5 over x squared dx. Oh, that works really good. Look, dx over x squared. Now, I don't want the negative 5. So divide both sides by negative 5. I'm going to get negative 1/5 out in front. This is going to be sine u du. Becomes real simple. It's going to be negative 1/5 cosine u, but I need an extra negative because that's going to pop an extra negative out, plus c. And the final answer would be 1/5 cosine of 5 over x plus c. All right. That one was kind of a little more interesting. 31, x squared secant squared x cubed dx. You could rewrite this as secant x cubed all squared. But I think I'm going to go with what's most inside x cubed, which I think I already feel I have a good feeling about this. X squared dx. Done with the 3. So we can get 1/3 in front. And it's going to be secant squared u du, which, if you integrate, it's tangent. U plus c. Final answer, 1/3 tangent of x cubed plus c. There you go. Did them all. Did the whole assignment in less than 15 minutes. I mean, I'm kind of fast though. I mean, I'm good. I always pause it, slow it down.